Hello, my dear students. Myself Riaz, your math faculty. I hope all you are fine and eager to study one new chapter, right? Good. So here we are going to discuss about plus one Max NCERT chapter called Limits and Derivatives. So my dear students, you can see from your textbook that it is a small chapter, but even though it will plays a major role in plus one as well as plus two. Why I am saying, because many higher concepts in differential calculus like continuity of a function can only be defined with the help of limits. So this topic have its own importance. So try to get all the concept here itself. No need of further delay. Is it okay? Agreed? Fine. So before entering to the chapter, I want to ask you one question, that is sine, cos, tan. Can we define these values? No. Why? Why we can't able to define? Yes, sine, cos, tan can be only defined with the help of an angle. Right? Very good. Very good. Right? Similarly, limits and derivatives can only be defined with the help of function. If there is no function means then there is no use of limits as well as derivatives. That is a key point you should be well known with. Is it okay? So what is the main agenda of this chapter is nothing but we are going to discuss the character or behavior or nature of the function at the neighbors of a point, not at that point, with the help of limits. That's the main agenda. What I told? We are going to study the function at the neighbors of a point, not at that exact point, with the help of limits. You got some idea, right? Later we can elaborate the idea through many different kinds of examples. Okay, let's begin. So right now you have heard with a word called neighborhood, right? So what is that neighborhood? So first one, that is neighborhood point of A. So what is that? So we are going to find the neighbors of a point. So for that, just draw one number line. So minus infinity to infinity, just mark A somewhere. So I want a quantity h for introducing neighbor, that is nothing but h greater than 0. So h greater than 0 doesn't mean that it is a bigger value. H is equal to 0 0.00 etc 001. Yes, negligibly 0. A small quantity, but it has some value. Okay, then what you want to do means just add this h to a. So what you will get? A plus h, right? If you subtract that h from a, you will get a minus h, right? So the values which are lying on this interval, you already know what you mean by interval in first chapter, right? So the values which are lying in the interval a minus h to a plus h, that is nothing but neighborhood points of a. That is nothing but neighborhood of point A. Is it okay? Don't write in short form. In the board there is no space. That's why I am writing like that. Fine. So what will be the values? What will be the values that are lying between A to A plus H? What? Right side. That which means a right neighborhood. Right neighborhood point of A. Is it okay? Fine. So what will be the values that are lying from a minus h to a? What will be the values that are lying in a minus h to a? There is nothing but left neighborhood point of. For example, that is, I want to find the neighborhood of 2. For that, I am taking an interval minus infinity to infinity. I want so far I am finding neighbors of 2. So I want an h that is positive real number, which is smaller and smaller value, right? It is very small value which is negligibly 0. So I am going to add h with 2. So what I will get is, I will get 2 plus h. There is nothing but 2.00 etc 001. Right? Then I am going to subtract that h from 2. That is, I will get 2 minus h. That is nothing but 1.9999. So 2 plus h will be here, 2 minus h will be here, right? So this much values will be its neighbors. So one more thing I want to say that a plus h can also be denoted by a plus. A minus h can also be denoted by a minus. So whenever you see this kind of symbol or notation means it means that is a plus h or a right neighborhood of a. Is it okay? And it is a minus means left neighborhood. Is it okay? Fine. So here I can write instead of 2 plus h as 2 plus as well as 2 minus. 2 plus h as well as 2 plus h as well as 2 plus are same notion. Is it okay? Both are same in meaning. Fine. So moving further. So throughout this chapter, you can see a notion that is this kind of notion you can see throughout the chapter. So it has its own importance. So try to get the idea. So our next topic is nothing but meaning this notion. But before that, what it is read as? It is read as x tends to a. X tends to a. What is it is read as? X tends to a. So what does it mean? X not equal to a. X not equal to a. X not equal to a. Then what it is? Yes, the value of x is near to a. The value of x is near to a. So right now you may have some questions. Sir, near to a means we can approach from both sides, right? Which one, sir? I am going to explain that. So whenever you see this kind of symbol means we can graphically show. Whenever you see this kind of x tends to a means we can graphically show minus infinity to plus infinity. A is here. This will be a plus h. This will be a minus h. A plus h can also be denoted by a plus. A minus h can also be denoted by a minus. So whenever you see x tends to a means we are approaching to a from both the sides, from right neighborhood as well as left neighborhood, within the neighborhood points of a. Once again, whenever you see x tends to a means what's the graphical meaning of that? You are approaching a from both the sides, from right neighborhood as well as left neighborhood. So my question is that from where to where my x values can vary? X values can vary from a minus h to a plus h, right? Is it? Okay. So what do you mean by x tends to a plus? What does it means? Which means graphically you can see here there is a, here there is a plus h or a plus, right? So you are approaching a through right neighborhood, That is the meaning of x tends to a plus. So where my x values can vary? A to a plus h. Very good, right? So at last, whenever you see x tends to a minus means, what does it means? That is, through graphically we can denote a is here, this is a minus or a minus h. So you are approaching to a from left neighborhood. So the values of x can vary from where to where? Yes, a minus h to a. Is it okay? Fine. So whenever you see these kinds of symbols throughout the chapter means this is the actual meaning of that. Fine. Okay. So moving to the next. At the beginning of the chapter, we were discussing that limits as well as derivatives can only be defined with the help of functions, right? So here we are going to define the limit with the help of function. All of you listen. For that, I want a limit. For introducing that, I want a function. I'm taking a function that is, I'm taking a function y is equal to f of x. I'm taking a function y is equal to f of x. So I told you we are going to discuss about the character of the function at the neighbors of a point. So for that I am introducing a point a. So what do you know how to get the value of the function at a? How to get the value? Draw a perpendicular line towards the function, and from there again draw a perpendicular line toward the y-axis. You will get the value. That value will be f of a. Just keep it there like that. So I am taking right neighborhood of a as well as left neighborhood of a. So we are going to find the value of the function at neighbors. So I'm taking first the left endmost neighbor. So I'm taking from that, I'm going to find the nature of the function. So draw a perpendicular line. Draw a perpendicular line. Okay, draw a perpendicular line. Then to get the value of that function at that point, what you want to do? Again draw another perpendicular to x. So we'll get a point here. Again take another left hand neighbor. Another I'm taking left neighbor point of a. So again for finding the value of the function, draw a perpendicular. So you will get the point here. Again I'm closing. I'm taking the left neighbor point and making them close towards a. Right. X is the values which I'm taking on the x-axis. I'm going closer and closer to a from left side, of course. So as you can see here, as our x values are approaching from left side towards a, the function is also approaching to somewhere right. Function is also approaching right. This approachness can be denoted by that approachness of the function as x values are approaching to a from left neighborhood can be denoted by limit x tends to a minus f of x. Is it okay? Is it okay? So what does it means? The approachness of the function or the value of the function at which x values are approaching from left neighborhood. So what about if I am approaching to the function, or what will happen if I am approaching to a from right neighborhood? What will be the value of the function? We will check. I am taking right endmost neighborhood. I am taking right endmost right neighborhood. So for finding the value, I draw a perpendicular. So suppose our function is going like this. So you can draw here. Again I am coming closer towards a. I am taking my x values from right neighborhood, which is closer and closer towards a. So what it will be happening? We will check what happens. So we will get a value here. Again making another right neighborhood which is much even more closer than towards a. So I will get right. So whenever I am taking x values from right neighborhood closer and closer towards a, our function value is also coming closer and closer, or function values is approaching to some value, right? So that approachness can be represented by limit x tends to a plus f of x. Once again listen, two approaches of the function we got from here. As we are approaching, or we are taking the values of from left hand neighborhood and getting closer and closer towards a, means our function also approaches to some value that is represented by limit x tends to a minus f of x. If I am taking the points from right endmost neighborhood and getting closer and closer towards a, means the function corresponding to that right neighborhood also approaching to some value, right? So that approachness of the function can be represented by limit x tends to a plus f of x. So whenever you see limit x tends to a minus f of x, that is nothing but left hand limit. So what do you mean by left hand limit? That is nothing but limit x tends to a minus f of x. So what do you mean by right hand limit? Limit x tends to a plus f of x. That is nothing but right hand limit. So these are the key points you should be known with. Is it okay? Fine. So you will get more idea through an example. I am taking one function f of x is equal to x square. You are well known with this function, right? What kind of function it is? That is, yes, quadratic function. What is the graph of quadratic function? Yes, parabola. So you are going to find the limit x tends to 2 f of x, you are going to find. Similarly, limit x tends to 2 minus 2 plus you want to find, as well as 2 minus f of x. So for that I am drawing one graph here. Okay, so maybe my 2 value will be here. So you know at the 2 what will be the value of the function? If you put x value input as 2, what will be the output? 2 square, that is nothing but 4. So if I am taking right neighborhood, that is nothing but 2 plus, right? 2 plus. So from 2 plus, what is this? What does the meaning? The approachness of the function as x value is approaching from right neighborhood. So I am taking right endmost neighborhood. So it will intersect to the function at this point. For finding the value, again draw a perpendicular towards y axis. So you can see you got a value here, right? So again I am coming closer towards 2. So I will get the value of my function will be again closer and closer towards which value, guys? 4, right? So nothing but limit x tends to 2 plus f of x is nothing but 4. As we are taking x values from right neighborhood, closer and closer towards 2 means function approaches to where 4. So the limit x tends to 2 plus of f of x is nothing but 4. Is it okay? So what about left neighborhood? If you are taking left neighborhood, that is here will be 2 minus. If you take an endpoint from left neighborhood of 2 means you will get a output here. So again I am going closer and closer towards 2 from left neighborhood. The function is also going closer and closer towards where 4. So limit x tends to 2 minus f of x is nothing but 4. So here you got both the left hand limit as well as right hand limit, both are same. So you may ask in every question like this. No, I will show another example. Listen carefully. I will show another example in which both the left hand right hand limit and right hand limit are different. Listen. For that I am introducing one function that is nothing but f of x. Function value becomes 1 if x greater than 1. Function value becomes 0 when x is equal to 0. Function value becomes minus 1 when x less than 0. Even x greater than 0, function value will be 1. Whenever x value is 0 means function value becomes 0. Whenever x value is negative, then function output will be minus 1. So what kind of function is that? You already studied from your first chapter. No, second chapter, relations and function. What was that function? Secant function. So what is the graph of secant function? So here dark circle, here 1 will be there, here minus 1 will be there. Whenever x is greater than 0 means function value is 1. So here 1 whole and then 1 line will be there. So whenever x value is less than 0 means function output is minus 1. So I am writing minus 1 here. Okay, then here again 1 whole and the values will go like this, right? So what you guys want to find? Left hand limit at 0, which means limit x tends to 0 minus f of x. So how to find it? We want right neighborhood as well as left neighborhood. Right neighborhood, left neighborhood. So for finding the value of the function for finding the value of left neighborhood, what I want to draw a perpendicular, right? So if I am drawing a perpendicular, so what will be my value? If I take each left neighborhood, what is the approachness of my function? That is nothing but minus 1, right? So what about the right hand limit? That is limit x tends to 0 plus f of x. That is right hand limit at 0. Okay. So what happened? Right neighborhood of 0 means for getting the value of the function, what I want to draw perpendicular. So where the value of the function approaches 1. So left hand limit is minus 1, right hand limit is 1. So both are different. So such kind of question also you can expect. Fine. So next we are going to discuss about a topic, existence of a limit. Existence of a limit. Existence of a limit. So when we can say a limit exists or not. So the definition is that limit x tends to a plus f of x. You have some value that is L. And you have another that is right hand limit, right? Right hand limit. Left hand limit, that is limit x tends to a minus f of x. The value of left hand limit as well as left hand limit as well as right hand limit, whenever both these guys become same means you can say that at a particular point a limit exists. Limit x tends to a f of x exists. What I told? Whenever the left hand limit as well as right hand limit both become same means you can say at the particular point function has limit exists. What will be the value? The same value of left hand and right hand. Is it okay? Existence of a limit. If if left hand limit is not equal to right hand limit, then we can say that what a limit does not or doesn't exist. Is it okay? If both limits are different means we can say limit does not exist. If both limits are same means we can say limit exists. Is it okay? Fine. Next we are going to discuss about algebra of limits. What do you mean? What is the addition of the function? How to find the limits of addition of functions? How to find the limits of multiplication of functions, two functions? How to find limit of division of two functions? Okay, we will say that is nothing but algebra of limits. So for example, there are two functions, that is limit x tends to a f of x plus g of x. Two functions are there in my hand, their sum is here. So you want to find the limit of combined function. What is sum of the combined function? How will you do? Nothing but just give limit to each person separately. That you will get limit x tends to a f of x plus limit x tends to a g of x. What I told? You want to find limit of sum of two functions means separately you just give. Same idea for subtraction also. So no need of writing further. So limit x tends to a f of x into g of x. What you will do? Same idea, just to give separately. So what is that? Limit x tends to a f of x into limit x tends to a g of x. So what about in the case of division? That is limit x tends to a f of x divided by g of x. There is nothing but give separately. That is what? Limit x tends to a f of x divided by limit x tends to a g of x. So one thing you want to get from here, that is denominator should not be equal to 0. Why? Limit x tends to a g of x not equal to 0. Why? If the denominator becomes 0 means the whole function will becomes not defined. So make sure that denominator not equal to 0. Fine. That is algebra of limits. So my students are eager to do some problems, right? Of course, we are going for problems. How to find the limit of the functions. By graph, you got how to find the limit, right? So it is not practically possible for drawing graph of each functions. So many methods are there for finding limits of some functions. Throughout the chapter, we will discuss about finding limit of a polynomial function, that is usually represented by polynomial limits. Second, we will discuss about for finding limit of trigonometric function, that is usually represented by trigonometric limits. Then third, we will find the limits of the exponential function, which can be represented by exponential limits. And later we will discuss about logarithmic limits. This much limits we will discuss throughout the chapter. Is it okay? So first one, we are going to find the limit of some polynomial functions. How we will find? Three methods are there. So first one, direct method. Second one, factorization method. Third one, using some standard results. So this much methods we will use for finding limits of a polynomial function. So you may get confused as for which method we will apply. Such kind of confusions will be there, right? No need of that. I will give crystal and clear ideas regarding each method. Which one you want to use? There will be no confusion. Okay? So for first we will solve the question by direct method. We will find the limit of a polynomial function by which method, my dear students? Yes, direct method. So first question I'm taking nothing but limit x tends to 2 x square plus 4. Already you have studied by algebra of limits. If you want to find the limit of sum of two functions, means what you want to do? You want to separately a limit for each one, right? I'm doing that. That is limit that is equal to limit x tends to 2 x square plus limit x tends to 2 4. In further question, no need of this kind of algebra, directly you can do. But for the first one, I am saying how the idea gonna work here. Okay, so by direct method, what you want to do means as x approaching to one value, right? Here which value x approaches 2, right? So you want to substitute 2 instead of variable term in the function. What I told? As x approaches to 2, so 2 is my approaching value. So this approaching value you want to take in your hand. So where you want to substitute for instead of the variable in the function, you want to substitute that value. So what will happen? Just see, that is here x square was there, instead of x I am putting 2, so you will get 2 square, that is equal to 2 square plus, here there is no x adjacent variable, so only one value is there, just put that value. So what is that? 2 square plus 4, 8. Simple only, right? Simple only, right? So what about the next question? Simple only, right? So direct method is nothing but just find the approaching value, taking your hand, then where you want to substitute instead of the variables in the function, just substitute that value, you will get the answer. So next question is nothing but limit x tends to 3 x into x plus 1. No need of algebra limits, directly you can substitute. So what happens? So approaching value is 3, so substitute instead of the variable terms in the function. So what you will get? 3 into 3 plus 1, that is nothing but 3 into 4, that is 12. Is it okay? Simple only, right? So one more question. Limit x tends to pi x minus 22 by 7. A polynomial function, right? So I told what? Approaching value is pi, so substitute pi instead of the variable term. So what happens? So here it is x, so it will be equal to pi minus 22 by 7. Does pi minus 22 by 7 is equal to 0? No, that is a blunder. If in the question they have given you that take pi value as 22 by 7 means you can cancel and put 0. Otherwise don't use the value of pi as 22 by 7. Why? The approximate value of pi is 22 by 7. The exact value of pi is not 22 by 7. Is it okay? Okay. This much okay. So at last one question from this section. Listen carefully, my dear students. That is nothing but LT x tends to minus 1 plus x square plus etc plus x raised to 10. LT, sir, what is this? Don't hear such kind of confusions. LT is same as limit. The another way of representation of limit, that is LT. Is it okay? Both are same. No need of confusion, okay? No need to be panic. Fine. So that method, right? We can substitute minus 1 for both the variable terms, right? How many variable terms are there? That much you can substitute that approaching value. I have a doubt for you, that is, does minus 1 and 1 minus are same? No. Minus 1 is an integer, right? 1 minus means what? 1 minus means what? Left neighborhood of 1. Both are different. Is it okay? So keep that in your mind. Keep that in your mind, okay? So listen, my dear students. So what happens? Substituting means what? I will get 1 plus. For this x I am substituting minus 1. So I will get minus 1 plus. For this x I am substituting minus 1. So minus 1 square plus etc plus. For this x again minus 1, the whole raised to 10. Any doubts? No. So 1 plus minus 1 is there. Minus 1 square means 1, right? Here it is, power is even, so the negative vanishes, 1 square, that is 1. Plus etc plus. So my power is even, so negative vanishes, 1 raised to 10, that is nothing but 1. So first one positive, negative, positive, negative. So here only positive is it. There is no further negative to cancel. So what will be the answer? This plus 1 will remains. So my dear students, that's all about that method. Any doubt is there? No. Shall we continue? Okay. So next we are going to find the limit of a polynomial function by factorization method. So first question, limit x tends to 2, x square minus 4 divided by x minus 2. So what is my question? Limit x tends to 2, x square minus 4 divided by x minus 2. Students, no need to confusion here, sir. There is no left hand limit and right hand limit. Later I will show one question regarding left hand limit and right hand limit. Right now we are approaching only to a point. There is no left as well as right. Only to that point. Okay. So you may ask, sir, can we use direct method here? Okay, we will use that method. We will see what is going to happen. So what happens if I'm substituting x as 2 means you will get 2 square minus 4 divided by, for this x also you can substituting 2. So 2 minus 2, it will be 4 minus 4 divided by 2 minus 2, that is nothing but 0 by 0. 0 by 0, don't get cancel and write 1, that is blunder. 0 by 0 means it is indeterminate form. We can't able to define further. So in these kind of question, don't use which method? That method. So right now you got when we can't able to use that method. When we can't able to use that method, if you substitute the value, the function will attain in the form of 0 by 0. At that time, don't use. So we can go for some manipulation. So at that time we can go for some manipulation. How we can able to manipulate the function here? Just tell me. It is in the form of, or how we can able to factorize. Limit x tends to 2. How we can factorize? That is x square minus 4 can be written as 2 square, right? Very good. Divided by x minus 2. Now you can see it is in the form of a square minus b square, right? So that is nothing but a plus b into algebraic identity. A plus b into a minus b. So substitute for that. So what we will get? That is limit x tends to 2, x plus 2 into x minus 2 divided by x minus 2. So x minus 2 gets cancelled. So what you will get at last? That is limit x tends to 2, x plus 2. Then you can use that method, right? So approaching value is 2. So substitute instead of a variable term x. So what happens? 2 plus 2, that is nothing but 4. Is this question easy? Happy? Fine. So one more question here. So many varieties of questions are there, but at least I'm doing 2 or 3 questions from each topic. Later we will discuss more. Fine. So another question, that is limit x tends to 3, x minus 3 divided by x square minus x minus 6. That is my question. So you may think, sir, can we go for substitution? Okay, just check for substitution. What happens? If I am approaching value is 3, so substituting for x, then what happens? 3 minus 3 divided by, okay, so approaching value is 3, so substitute for the variable means 3 minus 3, numerator, again here also 3 square minus 3 minus 6. Is it? So what happened? Numerator becomes 0, denominator 3 square, 9 minus 3 minus 6, that is 0 divided by 9 minus 9, that is 0 by 0. Again it will be in the form of indeterminate. So don't go for substitution method. So we can go for some kind of manipulation. Is it possible or not? Using factorization. So what we can write here? Here you can see, here it is a quadratic polynomial, right? How to factorize a quadratic polynomial? Here the quadratic polynomial is x square minus x minus 6. You already studied from your 10th class. By splitting the middle term we can factorize, right? So what is sum here? What is the sum? Minus 1, right? What is the product? Product is nothing but minus 6. So which are the two numbers? Minus 3 and 2. Very good. Minus 3 and 2. So how we can split the middle term? X square minus 3x plus 2x minus 6, right? So from both these two terms, who is common? X is common. So I'm taking x outside. So what happens? X minus 3 will remain from these two terms. From in these two terms, who is common? 2 is common. Plus 2 minus 2, plus 2. So plus 2 I'm taking outside. So what happens? X minus 3. In order to get the desired output, I'm taking plus 2 outside. Don't ask, minus 2 is also, we can take common set, don't use. We want to get the same desired factor there. That's why I have taken plus 2 outside. So from these two terms, who is common, x minus 3 is common, so take x minus 3 outside. If here I am taking x minus 3 outside, so what happens here? X will remains. Here what happens? Plus 2 will remains. So this quadratic polynomial can be factorized as x minus 3 into x plus 2. So what happens? Limit, I am interchanging x minus 3 divided by x minus 3 into x plus 2. So x minus 3 and x minus 3 get cancelled. What remains? Limit, is it okay? That is equal to limit x tends to 3 1 by x plus 2. Now you substitute, any problem is there? No, right? So instead of x, substitute this approaching value 3. So what happens? That will be 1 by 3 plus 2. That is nothing but 1 by 5. Simple only, right? Okay, fine. Then the last method, that is using standard results. How to find the limit of a polynomial function using standard results. How we can able to find? Listen carefully. Simply I can able to explain. So there is a standard result for that. Using standard results. So that is the result, x raised to limit x tends to a, x raised to n minus a raised to n divided by x minus a. What I told? Limit x tends to a, x raised to n minus a raised to n, the whole divided by x minus a, that is equal to nothing but n a raised to n minus 1. n a raised to n minus 1. So this is a standard result. So whenever you can see on the left hand side anywhere, just substitute instead of that n a raised to n minus 1. You want to make sure that in some question you can see not exactly same, some similar things will be there. So at that question, try to convert that form to this one and substitute the value. So make sure that the powers of x as well as a should be same as na. Denominator, this power should be 1, and you can directly substitute. Is it okay? So the question, that is nothing but find the limit of limit x tends to 1, x raised to 7 minus 1 by x minus 1. What is my question? Limit x tends to 1, x raised to 7 minus 1 divided by x minus 1. If you go for substitution also, it will be in 0 by 0 form. Factorization is not possible. So we go for standard result. So who is missing here? If here the 7 is there, means power 7 is there, means we can directly substitute, right? So can I write 1 raised to 7 here? That is limit x tends to 1, x raised to 7 minus 1 raised to 7. Can I write 1 raised to 7 is nothing but what? 1. So no problem. Divided by x minus 1. Now you can see. Is this one same to this? Same? Yes. What is my n value? N value is nothing but 7. What is my a value? A value is nothing but 1. Is it? So what is the output? N a raised to n minus 1. So what is my n? 7. What is my a? 1. N minus 1. So 7 minus 1. So what is it? 7. 1 raised to anything, that is 1 only. Is it okay? So one more question, finally, at last one more question, that is limit x tends to 3, x cube minus 27 divided by x square minus 9. What is my question? Limit x tends to 3, x cube minus 27 whole divided by x square minus 9. If you substitute 3, you will get in 3 cube 27 is 0, 3 square 9, 9 minus 0 by 0 form will comes. When if we substitute here, factorization also is not possible easily. So we can go for standard result. So how to convert this one to our standard result? Some similarities there, that's why we are able to convert. We can't able to convert everything to here standard result. Some similarities there means we can convert. So here you can see limit x tends to 3. Here power of x is 3. So try to convert the power of 27. Can we able to change 27 as a power of 3? Yes, of course. 3 cube is 27, right? X cube minus 3 cube divided by x square minus 9. Can we convert 9 as a square of any number? Yes, 3 square, right? X square minus 9. This much. Is it okay? Anybody having doubt in this much? No. Can I continue? Okay. So on the first in the case of algebra of limits, I told you what we can split the limit to each person, right? Here limit of a function divided by another function is there. Can I split? Okay, so what we can write, that is limit x tends to 3 x cube minus 3 cube divided by limit x tends to 3 x square minus 3 square. Then 9 can be written as 3 square. Okay, is it okay? Any doubts? So here you can see who is missing here, guys. In order to use the standard result, who is missing? X raised to n, 3 raised to n, both are same, powers are 3, no problem. But x minus 3 is missing there, right? If x minus 3 in the denominator, I can directly use the standard result. So there is no x minus 3, but simply I am dividing on the numerator by x minus 3. Simply can I divide? There will be problem, right? So I am just multiplying the same x minus 3. So no problem. They will get cancelled. Nobody have any problem. Is it okay? So here you can see x square minus 3 square is at limit x tends to 3. Same, right? But who is missing? Denominator is missing. Who is that missing, right? X minus 3. So simply I am dividing x minus 3 in denominator in order to use this result. You may don't ask why sir you are using this thing, because in order to use this result I am manipulating something. So I have divided x minus 3 in the denominator, so I should multiply x minus 3 also, otherwise these guys will make problem. Is it okay? So what we can do, x minus 3 get cancelled. Is it okay? Any problem? No. So what will be the final result? What will be the final result? Tell me, what is the n value here? N value here, numerator n value is nothing but 3, right? And a value is 3, right? A value is 3, n value is 3. So what about denominator? N value is 2, denominator n value is 2, a value is 3. So a value is 3. So I can write this thing as what? I can write this one, n a raised to, that is numerator 3 into a raised to 3 minus 1, n minus 1 divided by, here what about denominator? N a raised to n minus 1. So n is 2, a means 3, 2 minus 1. So what is the final answer? So 3 into 3 minus 1, 2. So 3 square will be here, numerator divided by 2 into 3 raised to 2 minus 1 means 3 raised to 1. So 3 will be there. So 3 get cancelled. So what will be the final answer? 9 by 2. Is it okay? So once again, every question we can't able to convert into standard result, but some similarity is there, means try to manipulate it and to convert them in this standard result, and we can use this result n a raised to n minus 1. Is it okay? So one last question, in the function is limiting at a point. The function is splitting at a point. So how to find the limit of that function? Listen, one question, the last question of this section. Later questions we will continue in further sections. So listen, the question is nothing but f of x is equal to 2x plus 3 x greater than 1. F of x is equal to 3 into x plus 1 if x less than or equal to 1. That is my function. So what you guys want to do means you want to find the limit x tends to 1 f of x. I hope you got my question. What is the question? The function has value 2x plus 3 when the x values, the domain values are greater than 1. The function has 3 into x plus 1 as my output value when x values or domain values are less than or equal to 1. So in these kind of questions, whenever the function are splitting at some particular intervals, what you want to do is just draw a number line. Then where is the function splitting at 1, right? So mark 1. So these values are right side of 1 will be what? X. So here minus infinity to plus infinity. So right side of 1 we can represent what? X values which are greater than 1. Left side means what? X values which are lesser than 1. Is it okay? Any doubts? No. X greater than 1 means what is my function? 2x plus 3. So mark here f of x, my function is 2x plus 3. So why you are doing like this? Because If you draw like this, you can easy to answer. That's why you simplify your steps. No need of much confusions. If you draw like this, there will be no confusions. Okay. So if x less than 1, what is the condition? Function value is equal to f of x is equal to nothing but 3 into x plus 1. This much okay? Anybody have doubts? No. At the x is equal to 1, what is my function? At x is equal to 1, what is my function? At x is equal to 1, what is my function? That is f of x is equal to 3 into x plus 1. Right. So you already know limit x tends to a particular point function. Limit exists means left hand limit and right hand limit should be equal, right? I'm going to check whether it is equal or not. So listen. So left handed limit at where 1, that is nothing but limit x tends to 1 minus f of x. The limit x tends to 1 minus f of x, that is nothing but limit x tends to 1 minus, what is my function at the left neighborhood? That is 1 is there, so left neighborhood is 1 minus, right neighborhood is 1 plus. So left neighborhood, you can see where is my function? Where is my function? That is nothing but a function is 3 into x plus 1. So substitute for the f of x 3 into x plus 1. Why I have taken 3 into x plus 1 as my function? At the left neighborhood, where if you draw perpendicular lines, the function will be this one, right? At the left neighborhood, the function is that one given in the question. Fine. So if limit x into 1 minus 3 into x plus 1 is there, means just no need to consider minus or plus, just to substitute that value as same as by that method. No need of further confusion. Okay, if there is 1 minus or 1 plus, means just to substitute that approaching value 1. No need of minus or plus, substitute in the question. No need of right or left approach, just to directly substitute that value instead of the variable. So here it is 1, so substituting means what I will get? 3 into 1 plus 1, that is nothing but 3 2s are 6. Okay, fine. Any doubts? No. So then right hand limit, that is right hand limit of 1 is nothing but limit x tends to 1 plus f of x, that is limit x tends to 1 plus, what is my function? 1 plus means right neighborhood of 1. What is my function? F of x is equal to 2x plus 3. So substitute that 2x plus 3. So 1 plus means no need of plus or minus, we just substitute that 1 in the question. So you will get 2 into 1 plus 3, right? So what is that? 2 plus 3, that is nothing but 5. So here you can see right hand limit as well as left hand limit of our functions are different. So we can say that LHL is not equal to RHL. Therefore limit x tends to 1, f of x does not exist. Is it okay, this question? Is there okay, any doubts? So from this chapter, so many questions are there pending. I told you initially only we have done the questions finding limits of polynomial functions. Many are pending there. Trigonometry is there, exponential is there, many so and so are there. So later we will discuss. I hope you understand. If there is any doubt, kindly let me know. Thank you.